Okay, ITS128. It's April 2nd, and if we look at the schedule, I guess we're in the last day of chapter 7. Let me switch over to my screen here. And let me log in. And I can't remember if I saved this or not, the last one. Population data. Yes, I did. Let me download this back down again. Put it on my desktop. And you recall this, for this problem, we're supposed to, below is a, okay, so let me go back to overview. Okay, so we are April 2nd, right here. We're getting towards the end of the semester. I'll have your stuff graded. I'll have your midterms and everything graded by next time I see you, I hope. If not, for sure, by next Tuesday. I want to get all caught up there. And so the assignment was to, you have this file called uspopulation.txt, and it's got the mid-year population of the United States in thousands from 1950 to 1990. Okay, the first line of so 1990. If you were born in 1990, that would make you 28. Okay, so was there anybody that was born in? Is there anybody born in this time period? I don't think so, huh? Well, between 1951 and 1990, was anybody born in between? Oh, well, I was. Just barely. All right, so you're supposed to, the first line contains the population for 1950. And the second line contains 1951 and so on, all the way up to 1990. And what you're supposed to do is to create an application that reads the file's contents into a list and then displays data similar to the following. Okay, so you recall I originally, when you first saw this assignment on Tuesday, I had array or list, and I didn't have all. I also did not have I wanted you also to display the value. So it displays the average annual change in population during the time period. That's what this increase is. It displays the year with the greatest increase. Oh, it displays, it displays the average annual increase. So it adds up all these increases and divides by however many years it is, which is 40 years, I guess. And then it displays the year with the greatest increase, which was 1955. And it displays the year with the least increase, which is 1967. Oh, sure. And what I also asked you to do was to actually display what the increase in population was in the greatest year, and actually display what the least increase was in the least increased year. So I also wanted to display what the value was for 1955 and 1967. And so I think I pretty much did the problem with an array, and so I think I have it here. Let me open this up. Let me start it up. Don't have to log in. And I have to find, I guess I have to find, yes, I do have to log in. Here we go. And so if we run it, where is it? Where's the? There's no. Oh, I'm choosing the file. Okay, so go to desktop and population, this one. And here we are. And here it is. It is, this is all the things, all the stuffs. 2384, which is what this says, 2384, 1955, 1967, 1955, okay. So that's what they are. All right. Okay, so, all right, so, and if we look at the code, we see that looks like this. And if we view the code, it looks like this. Okay, so we've got, all right, now you can do it this way or not. What I did was first, you recall that first I had a button here where you click on it and it asks you for the file. And once I did that, I got that to work. And then I decided I wanted to make it so once you start up the program, it automatically asks you the file at that time. And so the way I did it was I just copied the code out and I created my own method here, and I did it by refactoring. And so that way I was able to call this method when you clicked on the button, but I was also able to call this method when the form loaded. So you see, I named my method process population, and this is process population right here, down to here, and this method is invoked is called when either the form loads or when you click on this button. So the idea is you can, well, you can actually make a difference here. Let me just do some experimenting here. I'm going to make a copy of this. I'm going to open this up, and I'm going to, I don't know, I'm going to mess with it. I'm going to change all the, I'm just going to mess with it. I'm going to add, I'm going to take, I'm going to add, I'm going to add more lines to it. Okay, there I added some more lines. And I'm going to change the 20, I'm going to change it to 25, 5, 6, 6, 6, 6, I'm making this up. 7, 7, 7, 7, 7. I made up new numbers here. And I'm going to save this file as something else. I'm going to name this US population fake. So now I've got a second file here called US population fake. And when I start this up, I can first select US population and see this. And then I can click open file and select US population fake. And now it looks different. Because it goes up to the year 2001. Now, so some of you had to have been born in this range of populations. So anyway, so that's just some added functionality to this thing. By the way, I'd like you to make sure that you put some sort of comment in here, like Richard Halverson's population program. And I'd like you also to put, instead of form 1 up here, I'd like you to put why is it that I cannot? I'd like you to say Richard's population analysis program or something, some dumb thing like that. So that's up there. I'd like you to name these labels something different. Text can be, you can just put an asterisk there for that. But I'd like you to name this label something because you actually write to this label, so you want to have it named something. And I'd like you to use this convention, not the convention that they use in the book, but I'd like you to prefix labels with LBL output or something. And I'd like you to name this button BTN. I named it BTN open file. Name this list box LST data, population data or something. Something like that. Now, I'm just going to go over to the code and see if that changed it here. Yeah, LST population data, change the code there. LBL output, okay, change the code there. All right, now really what I'd like you to do though is the assignment asks you to use a list box or use a list instead of an array. So let's go through this code again real quickly. Let's see, it's 3:37. Don't want to spend too much time on this. We'll go to 4:30. The way this code works is we start out by opening the input file. Oh, first of all, I create a stream reader object, which is going to be able to connect to a file. that we're going to read, a text file. And I open up this dialog box to ask you to identify a file to read. That dialog box comes up and you're able to select the file. And then it uses this file, this open text method from this file class to grab out whatever the file name was that was returned from this dialog box here. It's going to return a file name, and it's going to connect this file with this name to this input file stream reader object. That's what's going on here. And then it's going to loop and read the stream, read the file one line at a time. It's a text file. It's going to read it one line at a time using this method here, read line. It doesn't read a character at a time, it reads a line at a time. Uses the read line method. And all this does, it reads it but doesn't put it anywhere, because all it's doing is counting. See, so this thing, all this loop does is count up the number of lines. Why are we counting up the number of lines? Because we want to know how big to make this array. Now, we could just make this array some big, huge array, which is a perfectly fine thing to do. In fact, that's probably how we would really do it. I mean, it seems kind of dumb that we would open up this file, read it up just to find out how many lines there are, so we can declare this array, this string array, which is that number of lines. And then we're actually declaring two arrays. We're declaring an array of strings called population, and we're declaring an array of integers called increase. And just so you know, the string array of populations is what's shown here. No, it's not even shown here. It's not shown. It's actually neither of them are shown. This is the increase. Never mind. So there's a string array which contains all the populations that are. It's these populations, but it's stored as a string. Okay, which is kind of silly. We could store them as integers. It'd probably be smarter to store them as integers, but we don't. We store them as strings just for this exercise. And then we're going to calculate the increase from one year's population to the next, and that's what's going to be stored in the string array here. And then we declare this integer called total. And as we are reading, so then we're going to read the whole thing in again. We're going to do the whole thing over again. We open it up again, brand new. Open it up like it's brand new again. And then we have this list box called list population data. And the first thing we do is we pop in this title here, just have a nice title at the top. And then we read that array back in again, just like we did before, except for this time we actually store, we do the same thing, input file read line, but this time we actually take the result out and store it into this population string array here. Remember, this is a string that comes in. Now, we could right here convert it to an integer. We could say convert int 32 or whatever and store this and make this an integer array instead of a string array. We could do that, but we didn't in this case. And then we also, but here we convert it. We convert the population of the one we just read in with the one we just previously read in. Now, we can't do that with the first one because there was no previous first one. The first time we read something in there, there's the first, when index is equal to 0, you know, index starts out equal 0, yeah? When index is equal to 0, there is no index minus 1 because we're still at the first one. So we have to wait until index becomes at least 1. That's why we had this if statement here. When index is greater than 0, then we can take a difference between what's currently read in and what was previously read in just the last time. We have to convert these to integers because we're going to do this calculation. And then that stores into this increase array we call increase. And then we take this index, which is going to start out by equaling 1 because we're waiting. This is the first time this thing executes. Index is equal to 1. We add 1950 to it, and so that's what gets displayed as the first year. It gets cast. This is a number, right? This is an integer number, but it gets cast to a string because it's a string here. We're adding a string to a string, so it's smart enough to know that we actually mean this to be a string, and so it puts a space in between, and then this is also an integer value, right? It increases an integer value right here, but it gets converted over to a string, and then that gets displayed out, and that's what you see in the list box. So it keeps on looping until we don't have any more population numbers to read in. And then we close it. Should have actually closed it up here too. We don't do that. And then we actually loop through this thing again. We loop through all the populations and we add up all the increases, and we divide by this number of lines that we divide by the number of populations that we read in, and then we are able to calculate an average. Now, there's some few things that we can do to improve the efficiency of this thing. First of all, it doesn't. I don't think we would really need to loop through again. We could do this thing. We could do that inside this loop here if we wanted to. So here, we actually have this loop. We have a lot of loops here. We've got a loop here that reads in all of the numbers for the first time to decide how big the array is. And we have a loop here to read in all the numbers of the array. And then we have another loop here to add up all of the increases. The increases get stored here. This adds up all the increases to figure out the average. And then we have another loop here to figure out what the maximum is, because we look at each one to compute what the maximum is. And then here we loop again to figure out what the minimum is. So there's looks like there's 5 loops. 1, 2, 3, 4, 5. Now, this seems inefficient, okay? It seems inefficient that we do these 5 loops instead of just trying to use as fewest number of loops as possible. I'll let you in on a little secret, though. In computer science, computational analysis of computational complexity, this does not, it does not really, it doesn't matter if we have, because we have a constant number of loops, okay? Whether it's one loop that does 5 times the amount of work inside, or we have 5 loops that each one does 1/5 the amount of work, it all adds up to the same. So it doesn't really matter that much if we have 5 loops that each loop does a little bit of work rather than one loop that does a lot of work. Okay, so that doesn't really matter that much. But the code is longer. It's more. It takes up more space. But you might want to combine it down into one. You can collapse it up and keep it in this. If you're using arrays, you can do it likely in two loops. So, but let's start looking at. We have about a half an hour here. Let's start looking at how we would do this if we were to implement this as a list, because that's more or less what the assignment is. All right, so to do that, I'm going to open up the textbook, vitalsource.com. And my library, it's this one. And it is, here we go, list collection. Right, oh, that's right. I must have been looking at this earlier today. All right, so we're doing chapter 7, lists. Yeah, let me see what's before this. Jagged arrays, McJagger arrays. Let me go back down to lists. Okay, so let's just look at this and see what we got here. List collection. .NETwork Framework provides a class named list, which can be used for storing and retrieving items. Once you create a list object, you can think of it as a container for holding other objects. A list object is similar to an array, but offers many advantages over an array. Here are a few. You create a list object, you don't have to know how many items you intend to store in it. Well, that's an advantage. We don't have to do that first loop. We can just like create the list and keep adding stuff to it. A list object automatically expands as items are added to it. That's convenient. In addition to adding items to the list, you can remove items as well. We aren't going to need to do that, but should we want to say, let's take out 1960. That was a bad year. We can just take it out, and the list automatically collapses up, and so there's only 39 years in there instead of 40. Whereas if we were to do that with an array, we would sure, we could take out 1960, but then we have this hole. So what goes in the 1960 slot? Well, I don't know, 0? I don't know. Well, we probably wouldn't want to have an empty slot there. So then we'd have to move 1961 up to 1960, and 1962 up to 1961, and 1963 up to 1962, and we have to shift them all up, okay? That can get expensive. Okay, that can, performance-wise, that can get expensive. You're probably wondering why do you, once we talk about all these things, you're probably thinking, well, why would we ever want to use an array? Well, the reason that we use arrays is because it's easy to access any item in the array in the same amount of time. If you want to access 1954, you just go, I want to do index number 4. If you want to access 1980, you do index number 30, okay? And it takes the same amount of time to find and grab the population for 1980 as it does to find and grab the population for 1954. Okay, so that's random access. Okay, so you can randomly access any item in an array in the same amount of time, in a constant amount of time. That's not the way it is with a list. If you want to access 1980, you got to start with 1950, and you got to traverse up the list. Actually, I think the list class provides you a method where you say what the index is, and it will return that index. But really, what happens is inside the class, it actually has to start at the beginning and go all the way up because the only way that you can get to 1980 is first get to 1979, okay? And the only way you get to 1979 is first get to 1978. Okay, that's how lists are stored. Okay. Anyway, so you can add and remove items as well, and the list automatically shrinks as items are removed from it. Okay, so for creating a list, this is how you create the list. So let's and you add stuff to the list this way, and you can loop through the list. Yes, you can index items in the list. You can, but it's internally it's not as efficient. It actually has to it takes longer to access the end of the list as it does to access the beginning of the list. It's better to use a for each. It's better to use this for each thing here. So if I were to start working on this and replacing this with a list, I would do something like, first of all, let me create a list here. So I'm going to say list. I'm going to call it. It's going to be an integer. No, it'll be a. Oh, I might also do it the same way. I'm going to do a string list. String. I'm going to call it pops. Populations. Populations is a new list of strings. Let me make this so left and right here. Is a new uh, a new list of strings. So this is how you declare a new list, similar to this here. This is a string. I guess I could declare it inside. Maybe I'll try to do it the same as here. Let me put it here. Okay, so I'm going to create a new list of strings here called populations. Okay, and then I'm going to I'm gonna see if I can do all this in one. Okay. Okay, and then I'm going to create another list of increases. So let me do list integer of increases. Inks, inks is a new list of integers. So I have a list of strings, which I'm going to call pops instead of population. And a list of increases I'm going to call inks instead of increase. And I'll leave the total there. I'm going to create a. I'll create a int. I'm going to try to do it all in this loop. I don't know if I can. I'm just going to see if I can. I'll int totes. Tote equals 0. And let's see. Oh, I'm going to do the min and the max too while I'm at it. Min, max, max year, min year. Okay. Int min. This is the minimum increase. Min inc equals 0. Int max inc max increase equals 0. This isn't going to work. I'll fix it later. I'm going to have max year int min year equals 0. I'll fix these later. I don't think I can initialize these. I can initialize. I can't initialize the min inc as 0, can I? What's the visuals? What's the C sharp maximum int? It's called int max value, isn't it? So I'm going to call that here. There we go. So the first new value I get for min inc is going to be less than inc max value. So And then, okay, so int max year equals 0. These don't matter. All right, now instead of read line, I'm gonna do where do I show? Oh, add. Okay, so I'm gonna do pops dot add parentheses that. So while I'm reading in counting, I'm also going to add them into my list. Let's see, inks. How can I handle inks? That's going to be tricky. I think I might have to have another loop for inks. My sister is autistic, okay, and so she wants to know when her haircut is on April 12th, and so she's going to be sending me text messages every 2 minutes until the class is over, and I'm getting the haptics on my watch. Zzz, zzz, zzz. No, I can, but whatever. I don't. Just, whatever. Just she's and and they're exactly the same text messages, and I know she doesn't copy paste. She just types them exactly the same each time. I should never have shown her how to text message. Anyway, that's fine. She's got nothing else to do, right? All right. So I'm gonna try to do it all in one. It's 4:06. I'm gonna keep. I'm gonna do something different here. I'm gonna say. I'm not gonna add it directly. I'm gonna do this. I'm gonna say. Uh, string pop in. I'm gonna say pop in equals input file dot read line. Okay, so it's going to read in pop in. String last pop in. Nothing. Number of lines. Number of lines is 0. So so pop in is that. I got to add pop into my. Add pop into my list, and then I'm going to say if number of lines. Well, I could say if the list is greater than 1. If list is there a size for the list? There is, right? List count. I don't need number of lines, do I? I'm going to use list count. If pop list count is greater than 0, then inks add pop in minus last pop in. Oh, I gotta integer it. I gotta parse int. Parse int. It's not. It's parse.int. Wrong language. And I gotta save what. I gotta store what the last pop int is. Should have done this earlier. Sorry. I actually did do this earlier, but I'm trying to be fancier than why I did it earlier. So we have the new pop in. Pop last pop in equals pop in. This is not right. This is int parse, isn't it? Wrong language, int parse. Using with JavaScript. Okay. So we read in the new population. We add it to the list, and then if the population is greater than population is at least 1, that means we have a last population. If the population count was 0, then we would not have a last population. As soon as the population becomes at least 1, then we've got a last population. That's going to be that. It's going to get filled in there. And then so that means when it comes around here, it'll have a value. So this takes the new population, subtracts the last population, and adds that to our increment, to our increase list. I also want to know what the largest increase is and the smallest increase is. So to do that, I want to actually I need to int increase. Is ink being used? I don't think it is, no. So I need to just calculate what this value is here. What's last pop? Last pop in. No, why it doesn't like that? This is going to work. It doesn't. Last pop in. This is, I'm going to say, this is ink equals this. Okay, so this is going to calculate the increase from this year minus last year. And then this is going to add it in there. And then, so I've got this increase, and here I got to do the calculation, the max ink, the min ink. Okay, so if ink is less than min ink, then two things. Min ink is equal to ink, and min year is equal to pop in. And that's going to be a problem. So min year. Min year is a string. Yeah, string min year, string max year. I guess I don't need this either. Okay, so if the increase is less than what the previous value I had for the minimum increase, if it's less than, and by the way, the first time it will be because it's initialized as the biggest number there is, then I want to store a new min inc year, a new min inc, and a new min year. And I know this isn't going to be both, so I might as well just do else. If inc is greater than max inc, if that's the case, then max inc equals inc, and max year equals pop in. All right, so that's that. And and I gotta display this stuff out too. How do I do that? Let's put this. What are all these squigglies here? Why do I have these new squigglies? Max, did I define a max here already up here? Oh, I did. All right. I'm gonna call them something different. It's 4:16. It's getting late. All right. So let me put. I want to put this thing up here. I'm going to put a new one up here. This is list population data. I'm going to put a new one up here. List box. List box. And a new label. LBL. So this is going to be called list box 2. This one is going to be called list box 2. Name list box 2. LST pop 2. And this is going to be called LB. What's this one? What's this called? This is called LBL output. This will be called LBL out 2. LBL out 2. Okay, so I've got that there. Oh, what did I just do? Okay. So I want to put this. This thing here. I'm going to put that up at the top here, and it's called LBL LST pop 2 or something. What I call it? Yeah. So it's going to add that up to the top, and okay, so fine. So it's going to put that there, I read in the population, read it in. I'm going to, that's fine. I'm going to do, I got the increase, I got the year. So, oh, it's going to be inside, it's got to be inside this thing. Okay, great. Okay, wait a minute. Yeah, right, okay. So now I'll go LST pop2, items, add, pop in, plus some spaces, plus pink. And when this loop is done, I'm going to do, what does this label out look like? Maximum increase. Well, let's see, it's 420. I got to leave some of this for you to do. Well, I'm going to do, it's after the while loop, I'm going to say LBL out to, LBL out to dot text equals max year equals what was the maximum year? MAXYR plus at plus max inc plus do a little return here, semicolon LBL out to dot text plus equals, make this min year equals plus min year plus at plus min inc plus. All right, I'm going to see if this works. I'm going to see what this does. Oh, some errors. 69, 70, and 39. 69, what's 39? 39 is, oh, what's the total for? Oh, total up to inks, right? Yeah, that totals up the inks. And what's 70 and 71? 70 is use of unassigned local variable. Max, min year, max year. In year, max year. How can that be? Oh. All right, let me just do this. Ooh, boy, that doesn't look right at all, does it? What am I reading in? Oh, I'm reading in populations, not years. Oh, these are the populations right here. Okay, but the increases are correct. Okay, okay, it's close. All right. So, well, the year is okay. All right. I'm not display. I should not be displaying out. I should be displaying out. Oh, I shouldn't be displaying out pop in. I should be displaying out. 1950 plus pops count. Yeah, that's what I should be displaying out. I think. Let's see what that does. Expected. Oh, excuse me. All right, well it's getting there. All right, so I'm off by one. See, I'm off by one. So this is somehow, see, 58 is 399. This 57 is 3099. So this is the increase from the 0th year. Um, oh, and max year is not pop in. Yeah, it's this. Should be this. And the first one shouldn't have anything in it. It's just like int is a string. Yeah, yeah. I guess my problem is I still got that first off by one thing. So what's the cause of that? Oh, it should be 1950 greater than 1. Should be 1, 1951. Increases, something's funny with the increase. Increase, this is max. The first one is max. Oh no, we're writing it out here. Writing it out. 1950 plus increase. This is the first one is going to be increase. The first one is pop in plus last. Oh, oh, shoots. Um, if this is added in here, okay. Oh, ah, this has got to go afterwards. There we go. There we go. Let's see if this works. There we go. Oh, yeah. Let me just fix this. Um, All right. Yeah. Okay. So there. So what that means is if I wanted to, I can get rid of all of this. What's a fast way to get rid of that? I can just do dun, dunt, dun, dunt. And just does one. So the other stuff doesn't show like because none of that gets filled in, but all this gets filled in, and it's just all done in one loop, and it's done with a list. So I don't have everything here. I don't have the rest of the assignment. I don't have the average increase. I don't have, but you know, it's kind of messy. But there you go. So you should be able to watch this video and look at the code and do the assignment. If you have any questions, you can ask me on Thursday. All right, it's 4:30. So, all right, how do I unshare this? Okay, thanks for watching.